Wonderful to be here today. I live in New Zealand, which is conveniently located on this map. I have 2 cats, and they're often helping me with my programming. Anyway, enough about cats. In 2017, I imagined a different way forward for Ruby. What if concurrency could be efficient, scalable, and elegant? What if Ruby applications could handle massive load without needing massive infrastructure? And how would that change the way we build web applications? That idea became the seed that grew into the Ruby gem called Async and the web server called Falcon. Looking back, I realized this wasn't just about my own frustration, it was about Ruby itself. Concurrency offers real value, improving efficiency and enabling new application designs. The scope is enormous. Ruby powers millions of applications and is loved by developers around the world. And when you multiply value by scope, you get impact, a chance to transform Ruby and how it is used, making it better for everyone. In other words, even if you do something of great value, without scope, it will have little impact. And over the past 10 years, I have come to realize how important this way of thinking is. A few years later, at RubyConf Taiwan in 2019, I gave a talk called The Journey to 1 Million. That talk was about how I introduced fiber-based concurrency to Ruby, making fibers both practical and efficient. I gave a demo showing that 1 million WebSocket connections per server process was possible with Ruby using fibers. Later that year, at Ruby World Conference 2019, I talked about climate change. The tech sector produces around 2 to 4% of global emissions, and inefficient software is part of that problem. Building efficient, scalable systems means using fewer resources to achieve the same outcome, and that's better for the planet. Today, I'm here to talk about Falcon, a web server that uses 1 fiber per request. Because fibers are lightweight and cheap to create, they provide more opportunities for concurrency. This year, we deployed Falcon to production at Shopify, replacing some existing Unicorn and Puma deployments. It's now handling about 30 billion requests per day. That's a big number. Thousands of servers were retired as a result by consolidating the workload onto Falcon. And this simplification saved us millions in operational costs. It also greatly reduced our physical footprint. So every time a company adopts Falcon, I feel one step closer to my goal, making Ruby more efficient, scalable, and elegant. We handle more load, using less servers, and we can keep using Ruby. But this is just the beginning. For a long time, this was a personal journey. Now it's time to focus on growing Falcon's adoption. We've proven that it works at Shopify scale, and I want you to replicate this success with confidence. So here's how we'll approach it. First, we'll look at building with Falcon, specifically how to use it with Rails to create high-performance web applications. Next, we'll cover deploying those applications to production, making sure you know how to use the tooling correctly. And finally, we'll talk about monitoring applications on Falcon so you can keep them running smoothly and reliably. Building a great application with Falcon has never been easier. But before we talk about that, let me bring everyone up to speed on Falcon and the underlying technologies. So if you didn't know, Falcon is a web server built on top of Async, a framework for concurrency in Ruby. And Async is built on top of the I/O event gem that provides the event loop implementation. It coordinates with Ruby using the Fiber Scheduler interface to manage the execution of fibers. The Fiber Scheduler interface exposes a set of hooks, and together, these form the essential plumbing of Async. The Async gem provides high-level building blocks for concurrent programs, and this powers Falcon. Falcon itself uses Protocol Rack to run web applications in a fiber per request mode, unlocking the scalability of the event loop design. And on top of Rack, we use Rails to build your application, alongside a variety of related technologies. So today, we're talking about how to use Falcon with Rails, but many of the things we talk about apply to any rack-compatible framework. Let's start by creating a new project. We're going to remove Puma and replace it with Falcon. Now we can launch the Rails web server. Notice it says booting Falcon. And if we open the application in a browser, we see a familiar page. But this is HTTP 1.1, a protocol that was established almost 30 years ago in 1997. Surely we can do better. Let me introduce the Falcon serve command. It defaults to HTTP 2 with TLS. That's because HTTP 2 in the browser requires TLS encryption. And it's a good idea to develop and test in the same environment we're deploying to. However, if you open this in a browser, you'll get a warning because the TLS certificate is not recognized. We are going to solve this problem using the localhost gem, which provides self-signed certificates for local development. So let's run the bake localhost install command. We'll be asked to authenticate with the system, and then a development certificate will be installed. Now, instead of this, we'll get this. And we can confirm that it's running on HTTP 2. The localhost gem also works with Linux. Falcon is the only rack-compatible server that delivers HTTP 2 and TLS by default, which makes it a great option for developing modern web applications. Okay, so we have the basics working, but one question that often comes up, does it work with Active Record? Actually, Falcon is extremely good at non-blocking I/O, including database queries. But Rails still defaults to one database connection per thread, which is unsafe when running with Falcon, since Falcon can handle multiple requests on the same thread. So we need to add this configuration to our config application file in Rails. The first setting prevents Active Record from being used in a way that can leak connections, which is actually good for any modern Rails application. And the second setting instructs Rails to use request per fiber isolation, ensuring that each request gets its own database connection. With these changes, everything just works on Rails 8. Thank you. So here is a small example. Basically, a pizza oven where we create a new pizza, inserting it into the database. Then we cook it, which updates the record in the database to cooking, sleeps for a short duration, and updates the record again. When we run this example on Falcon and Puma, at low levels of concurrency, we don't see much difference. But once we start increasing the number of connections, we see significant improvements in Falcon's performance. Now, you might argue, let's just increase the number of threads. Surely it's not fair that Puma only has 3 threads and Falcon can create unlimited fibers. Okay, let's try that. So even with more than enough threads, Puma can't match Falcon's efficiency, and the gap only grows as the connections rise. Of course, this is a specific benchmark, but we got over 200% throughput with the same hardware resources. So Falcon has great support for Active Record. Okay, now let's talk about Active Job. Active Job works fine with Falcon, but existing job runners like SolidQ and Sidekick are not async aware. As with Puma, we expect to see similar concurrency limitations, especially when I/O is involved. So I built async job to unlock greater concurrency for background jobs. Let me show you how it works and how you can use it. Now, async job is just a generic queue interface, which means it doesn't actually know how to serialize or execute jobs. In brief, we enqueue job data into the queue and then later dequeue it. The queue itself could be in memory or using a database or using Redis. It's an internal detail. So we need to wrap the interface, the queue, with the interface expected by Active Job. In essence, we need to serialize the Active Job, pass that into the queue, and then later on deserialize and execute it. So this functionality is provided by a separate gem that connects Active Job with Async Job's queue interface. It's a nice design because we can directly execute jobs without any additional overhead. Most other adapters have wrappers that make job handling more complex. Let me show you the Sidekick queue adapter for Active Job. See here, we actually have a job wrapper, and the sole purpose of that wrapper is to execute the Active Job itself. So what we have is a Sidekick job that contains an Active Job. In In contrast, the async job queue adapter directly invokes active job. There is no wrapper. Here is the async job queue executor for active job. We directly deserialize the job data, and then we execute it. It's a cleaner design with less overhead. So to use this, you need to install the async job adapter active job gem to your project. Then we need to define the queues for job processing in your Rails application. We're going to define two queues, a default queue and a local queue. The default queue is going to use an aggregation to batch jobs into Redis. This avoids latency during job submission. And we're also going to include a local queue which processes jobs in the background within the same process. This kind of queue can be exceptionally fast, but less reliable. Then, if we want to use async job exclusively, we can set the global queue adapter in config application. Alternatively, in our job definition, we can set the queue adapter here, and we can also specify which queue to use per job. I compared async job with Sidekick, and they were both pretty similar, but async job performed extremely well. Note that the Redis processor for async job has many of the same reliability features as Sidekick Pro, although it's definitely not as mature. I also had feedback from a user who compared solid queue with async job and found it was a significant improvement, but I didn't perform this benchmark myself. So for fun, I created a small demo that combines active job, active record, and action cable. Here is the active record model that broadcasts to an action cable stream when it is created. And here is a background job that creates that model. And here is the controller that creates a background job. This is the view for that controller. Here is the form which lets us submit the request to create the job. And here is the table which is updated when the record is created by listening to the job execution stream. So let's open the demo in a browser. In the console, we can see the browser successfully connected to action cable using a WebSocket. Then if we submit the job, we can see in the logs that the job was enqueued and the new record was sent over the WebSocket to the browser. Then the table is updated. So we can see that Falcon works very well with active job, and you can choose to use async job queue adapter if you want better performance. So that demo was using Action Cable, which only supports HTTP 1.1. But Falcon defaults to HTTP 2, so how is this working? Well, it turns out that most browsers, Safari, don't support HTTP 2 WebSockets. Instead, they make a separate HTTP 1 connection, except for Chrome, which tries repeatedly to connect using HTTP 2, failing every time. To fix this, I created Async Cable, a gem that replaces Action Cable's implementation with Async WebSocket, which supports both HTTP 1 and HTTP 2. Now if we go back to our example, notice that the WebSocket connection is working correctly, and we can see that the status code is 200 OK, which indicates an HTTP 2 WebSocket connection. If this was HTTP 1, we would see 101 switching protocols. In addition, Async Cable performs better than Action Cable. I did a quick benchmark, and Async Cable had more than 2x the messaging rate. So Action Cable is supported, but with Async Cable, you'll get better compatibility with HTTP 2 and improved performance. Now, Action Cable is okay for some use cases, but if you need ordered message delivery or simply want more control over the message stream, you might want to use a streaming response. One of Rank 3's major features was real-time bidirectional streaming. And we can take advantage of that to deliver in-order messages. For example, this classic song, 100 Bottles of Beer on the Wall. Here we create a body proc, which takes a stream argument, and we write to that stream one line at a time. Then we respond with that body proc, which the server uses to stream the output to the browser. You can use this technique to implement basic streaming, server-sent events, or even WebSockets from within a Rails application. Of course, that example is a bit boring. How about this one? I'm sure some of you have seen this demo already. It's actually a Rails web application running Flappy Bird in the browser using server-side rendering. The user input is streamed to the server, and the HTML is streamed back to the browser using an async WebSocket. I've actually heard this one supports multiplayer. So Falcon offers excellent support for real-time interactive streaming, giving you more control and flexibility, enabling new experiences for your users. Okay, so in summary, Falcon defaults to HTTP 2 with TLS self-signed certificates. Active Record is fully supported in fiber mode. Active Job works fine, and you can take advantage of Async Job for improved performance. Action Cable mostly works, but Async Cable resolves compatibility issues with HTTP 2 and improves performance. And finally, Falcon has great support for bidirectional real-time streaming using Rec 3's official specification. Now, you've built this wonderful application with Falcon, but how do you deploy it? During development, we used Falcon Serve, but it's not designed for deployment. Basically, because it's hard to configure all the options you might need in a production environment. So now let's introduce Falcon Host. This command reads a Falcon RB service configuration file that defines how to run your application. Let's take a look at a typical configuration file for a Rails application. Firstly, this is actually an executable script using Falcon Host as the script interpreter. Then we define a service using the host name of the application we want to run. The service includes the rack and Let's Encrypt TLS environments. Those provide all the default configuration we want for deploying a standard Rails application. Now we can run the application. It logs that it's binding to a Unix domain socket named application IPC. This is the default because the expectation is you'll use this configuration as part of a reverse proxy setup. Alternatively, if you want to bind to a specific port using unencrypted HTTP, we can write the configuration like this. Here we specify a custom port and endpoint. Now when we run the server, it binds to the endpoint we specified, listening on port 3000. Actually, this service configuration file is implemented by the async service gem, and it's possible to include other services. For example, we can also include the background job service as part of our web application. This service includes the async job adapter at the job environment, which runs our background job queue. And if we run our web application, we look at the process tree, we can see both our Falcon server processes as well as our background job processes. So Falcon RB defines your deployment, including all your services, making it easy to deploy anywhere. So this is the basic strategy for hosting a Falcon application. But what about virtual hosting? Let's talk about Falcon Virtual. In the past, at least, it was very common to host multiple applications on the same server. Falcon Virtual lets you run multiple Falcon RB service files and binds to both insecure HTTP as well as secure HTTPS. The insecure endpoint, plain HTTP, redirects to the secure HTTPS endpoint. And the HTTPS endpoint supports hostname negotiation to select the correct application. So it's really that simple to implement virtual hosting with Falcon and host multiple applications on the same server. Let's talk about systemd integration. The async container that runs each service supports multiple process readiness protocols. That's the mechanism that says, hey, I'm ready to go to the parent process. And we have built in support for type equals notify, which is basically the best process readiness protocol to use in systemd. Then all we have to do is run Falcon Virtual, and we can pass in a wildcard for all the web applications we want to run. So Falcon has great support for systemd and integrates directly into the service framework it provides. This makes it exceptionally easy to use with minimal configuration. Alternatively, if you're using Kubernetes, we also have support for that. Because of the way Kubernetes is designed, we need to use a log file to communicate with the readiness probe. So we specify the notify log environment variable, and then we can use this command to poll the log file. For the liveness probe, using an application-specific check is better. Rails already includes an HTTP endpoint for the health check. Here is an example of what that looks like. So you can just use that directly. To be honest, I wish Kubernetes followed the same model as systemd. It feels a bit ugly to have to use a log file, but it works well enough. Okay, so in summary, we've shown how to use Falcon host with a Falcon RB service file. We've shown how you can add multiple services for simplified deployment. Then, if you have multiple web applications, you can use virtual hosting. To actually run this, we have good support for systemd using Notify Socket and Kubernetes using Notify Log. Okay, so you've built your application and deployed it, but how do you know it's performing well? Underpinning Falcon and async service is async container, which manages all the child processes. That also includes health checks, which are an important and automatic part of keeping your application online. Specifically, if a child process hangs or the event loop stalls, it will be detected. If that happens, the child process will be forcefully restarted. Here is an example log showing a health check failure and the subsequent process termination. So by default, critical issues in your application will be detected by the health check. In addition to that, there is a special service which can run adjacent to your web application called the supervisor that can perform various functions from monitoring memory usage and detecting memory leaks. In your service definition, you can include the supervisor. We do this by creating a new service block and including the async container supervisor environment. We then tell the other services that they should report to the supervisor that they are supervised. And then we can instruct the supervisor to monitor those other services. For example, here we impose a 400 megabyte limit on all supervised services. If a memory leak is detected, then the supervisor can take various actions with the child process, including dumping its memory for later debugging and/or terminating it. Memory limits are extremely important to general application health, as without them, the operating system will eventually start killing processes, which can create instability in your application. In addition to this, you can create your own monitors and hook into the supervisor to keep track of any specific details you care about. So the supervisor service provides a robust framework for monitoring your application, including memory usage checks to ensure application stability. Now let's talk about how to trace your application execution with the traces gem. Tracing execution of your application is a useful way to measure performance, including monitoring the latency of various operations during the execution of a request. Here is a small example showing a single request that took about 10 milliseconds, of which most of that time was spent rendering the response. On more complex examples, you might see database queries, cache lookups, or other services, giving you insight into the performance of your application. Anyway, there are many providers for tracing, and the vast majority of them have libraries of monkey patches to add instrumentation to existing code. But I wasn't really happy with this approach. It was too invasive and fragile, and I especially didn't want people monkey patching my libraries. So I decided to be proactive and create the traces gem, an interface which allows you to optionally instrument existing code with minimal overhead. So here is an example of how to provide traces for an existing class. Here is the method we want to trace. And so we define a trace provider for that class. And then we wrap the method in a trace using super to call the original implementation. If you run this code with tracing enabled, you will see that a trace is captured for the method call. When I originally built this traces gem, many of the providers were defined in line with the code, and that made it impossible to disable them. So I'm taking a different approach now. For new providers, they are defined in separate files which have to be loaded explicitly, which gives you control. So you can get a list of all available providers in your project by running bake traces provider list. Then you should create a configuration file, config traces, and add the providers that you're interested in. We also need to add the traces gem and a suitable backend to our project. Then, to enable tracing, specify the traces backend environment variable. If you do this, you can get full tracing of each request like this. Also, async HTTP supports distributed tracing according to the W3C tracing specification. So if you use it for both the client and the server, you get tracing between services. There is also an open telemetry backend for tracing, which I think going forward will be the preferred choice. So application tracing is an extremely powerful tool which can give you valuable insights into your application performance and is fully supported by Falcon and the wider async ecosystem. Now let's talk about metrics. Metrics are things like counts, durations, or sizes, and they are measured in aggregate, meaning they can be efficiently stored in a compressed time series database. The metrics gem is also has a similar interface to the traces gem. So here we have a method that we want to measure the call count. So we define a metric for call count of type counter. Then we wrap the method and increment the metric. It's very similar to the traces gem in that all you need to opt into metrics are in that you need to opt into the metrics that are relevant to your application. You can get a list of available metric providers using the bake metric provider list command. Then you should create a config metric file and add the providers that you're interested in. Like traces, we also need to add the metrics gem in a suitable backend. Next, to enable metrics, specify the metrics backend environment variable. And so after collecting some data, you can draw some pretty graphs like this one, which displays finished HTTP requests by status code. I got asked recently, when should you use metrics and when should you use traces? In addition to that, if you're experiencing issues, you might want to use a profiler. So basically, a profiler can capture every detail of your program's execution, while traces capture specific parts, and metrics count specific events. They help you answer questions, different kinds of questions, like how did it fail, or what failed, or did something go wrong? But there are different costs. A profiler generates more data and has a bigger overhead, while metrics capture less data and have a much smaller overhead. So what kind of instrumentation you use will depend on what kind of questions you are trying to answer and what kind of cost you're willing to accept. So application metrics are a useful way to track high-frequency events and detect error conditions, and they are well supported by Falcon. Finally, let's talk about logging. The console gem provides a simple logging interface with multiple adapters and outputs. We use a subject-based log format where the first argument is the subject of the log, and we can also include structured data. Here are some more examples showing the different log levels in error handling. The console gem is flexible, and you can enrich or redact log messages by adding output wrappers. Here is an example that adds log correlation based on the Datadog trace context. Now when we emit logs, they will be attached to the specific request, which can be extremely useful for debugging. There are also several adapters to integrate existing frameworks with the console gem for logging. For example, console adapter Rails gem. It provides structured logging for key operations in Rails. So Falcon has great support for unified logging via the console gem. So in summary, we have automatic health checks to detect hangs and stalls, a supervisor framework that can detect memory leaks and supports custom monitors, flexible application tracing including distributed tracing, application metrics, and unified logging with flexible processing and trace correlation. So we have talked about building and deploying and monitoring Ruby web applications with Falcon, but that was a lot of information. Do you remember it all? Fortunately, there is a simple solution. Let me introduce the Falcon Rails gem. Where possible, it includes many of the things that we talked about today, by default including, of course, Falcon, localhost, async job, async cable, traces, metrics, and console. But that still requires you to do actual work. So let me introduce the agent context gem. This gem copies documentation into your project suitable for an AI agent. So now you can just ask Claude to do all the work. Claude, consult agents.md and update my application to use Falcon. So there's really no excuse not to try this out. Together, let's take Ruby to the next level with async, Falcon, and Rails. We've proven it at Shopify scale. We have full support for Rails 8. You can build the next generation of interactive applications to delight your users. The deployment process is super simple, including comprehensive monitoring. So be the next success story, building, deploying, and monitoring Ruby web applications with Falcon. Okay, so here's my text editor. First, we're going to pull in RubyGem sources. And then we're going to add 2 gems, lively, and gem agent context. And we'll just install those dependencies. And we're probably just destroying the network now. Oh, I had a typo. That always happens. Cool. And then we're going to run the command bundle exec bake agent context install. And that will create this directory over here called context. And in here you'll see this documentation, including for lively. But also pretty much everything we talked about today is in this directory now. So, okay, now we're going to go over to Claude and say, hello, Claude, you are on stage at Kaigi on Rails. Could you please make a Kaigi on Rails themed game using lively? And of course, you can like decide what kind of theme or whatever you can choose if you're doing it yourself. And if it works, then I'm going to claim all the credit. And if it doesn't work, then I'm going to blame the AI. And you'll notice that it picked up this file called agents.md. This is another part of agent context. So this file is automatically generated when you run bake agent context install. And it is an index of all the documentation that's been installed so that Claude can figure out which things it needs to look at. And so you notice here it's found getting started guide and the worms tutorial. And so it's going to have a go at probably doing something like that. Now, while I'm waiting for that to happen, I'm going to show you this demo over here. How are we doing for time? Oh, yeah, still got some time. So this is a demo called Falcon Rails Examples. And this pretty much has examples of everything we talked about today. If you scan the QR code, you can find that GitHub repository. I'll leave it on there for like 10 more seconds. Okay, so let's have a look at some of the demos. There's a bunch in here. So here's a streaming demo. And this one is using it's the 99 Bottles of Beer song. And so this is just using Rack 3 streaming, running inside a Rails application in real time. It's not really bidirectional, it's just the server sending us data. Now let's have a look at the chat example. Hello from window 2. And it shows up over here. Hello from window 1. That shows up over there. So that's using Redis, PubSub, I think, and real-time communication between the client and server. This is a really simple game that I really like. It's called Robot Finds Kitten. And you basically are this robot character, and you have to move around and find things. Specifically, you have to find the kitten, right? So once you, it's not really a game. There's no real challenge, but it's a metaphor for life, which is why it's so great. Here is a background job example. We can choose the queues that we talked about, and we can just add a delay for the sake of making it interesting. And it's using turbo streams and whatnot to update the table. And the local queue is running in process, and the default queue is running using Redis. Here's an Olama example, which is using async Olama to talk to an LLM. Might take a while to load the model. We'll come back to that one. There's the Flappy Bird example that everyone loves. Is this working? Press space to start. Oh, there we go. And so that's running inside Rails, real-time bidirectional. This one is not the multiplayer version. It's not a great version. There's better versions, but it's still good. And then service-end events. And this one is just a clock. It's pretty boring, but it shows how to do service-end events with Rails. By the way, in this demo, you can click on these files here, these links, and it will take you to the code. So if you're just browsing through and you want to see how it works, just click on the link. Cool. Let's see if that loaded. Hello. No, I don't know what's. Oh, no. Oh well. Never mind that example. Okay. Yeah. Okay. So it's finished. Let's see if it worked, and if it didn't, I have another one that I did earlier. So. Yeah, I know we have the dependencies installed already. Okay, yeah. Okay, it started it. Okay, wish me luck. Oh my God. Yeah, I don't actually know what's going on. It's like I don't know what I'm supposed to do. Stay within the conference bounds, and I've got 3 lives and there's stars. I'm gonna get stuff. What are the red dots? Are they good or bad? I don't know. I have no idea what this game is supposed to be. Ruby gems, 100 points, grows your tail, bugs, -1 life, Rails, 50 points, speed burst. Okay, the rail is a speed, oh, wow. Okay, I think I just died. Anyway, look, one of the goals of doing this live vibe coding and trying to get some people involved is to show you like how easy and how much fun Ruby can be. And when we have great technology, it allows us to build great things and be creative and do things that we couldn't have done before. So I hope that you all go away and you build something with this framework. And if you do, please share it on X, and I'll enjoy looking at your projects. And with that, I'm finished. Thank you very much.